Friends, the next experiment is to determine the strength of the given solution of hydrochloric acid by titrating against the standard sodium carbonate. You see, here we are using standard sodium carbonate. Here we are using standard oxalic acid. Here that is an acid, this is the base. Sodium carbonate, you see, sodium carbonate is equivalent to sodium hydroxide. Fine, suppose your sodium hydroxide is not available in the laboratory, you can take very well sodium carbonate. For titration purposes, in the place of sodium hydroxide, you can use sodium carbonate very well. Because sodium carbonate is a salt of strong base and weak acid. The strong base is your sodium hydroxide and strong base is your sodium hydroxide and weak acid is your carbonic acid. So this is a salt of strong base and weak acid. And you know, except strong acid and strong base, other acids are getting hydrolyzed or reaction with water. Hydrolysis is a chemical process where water takes part in the chemical reaction. So sodium bicarbonate, when it takes part in chemical reaction with water, you will get two new substances, that is your sodium hydroxide and carbonic acid. Carbonic acid is a weak acid, it is a very weak acid, so your sodium hydroxide dominates. So sodium carbonate will behave as a strong alkali. It will behave as a strong alkali. So you see, this is your alkali. Strong alkali. It will give you sodium hydroxide by hydrolysis. Hydrolysis is a chemical reaction where water is one of the reagent. Water is one of the reagent that takes part in the chemical reaction. So you see, this is your sodium carbonate, and sodium carbonate will be taken as primary standard. This is taken as primary standard because it is a stable compound, stable crystalline compound, and it is not deliquescent or efflorescent. ये बाहर सोडियम कार्बोनेट से नाइट्रस इफेक्ट, so primary standard is not never taking its weight, never changes during taking its weight. So sodium carbonate is a stable and pure compound, and we can take it as a primary standard. But hydrochloric acid is prepared by dissolving hydrogen chloride gas in water. So that cannot be standardized. That cannot be standardized easily. So that for this, that you can call it as a second standard, and that hydrochloric acid is to be standardized against a primary standard alkali, and that is called sodium carbonate. Sodium carbonate is a salt and it becomes alkali on hydrolysis. Sodium carbonate is not alkali. Sodium hydroxide is an alkali. But sodium carbonate is a salt, and that salt gives you strong alkali, that is your sodium hydroxide. But what means by treating with water in the process of chemical reaction is called hydrolysis. And it is a salt of what type? It is a salt of strong base and weak acid. Salt of strong base and weak acid. And it is alkaline in nature. So you see, this is a primary standard. So how to prepare N by 10? Let us prepare N by 10 or N by 20, N by 10 of sodium decimal mass solution of sodium carbonate. Sodium carbonate molar mass is 106. 106. So, student, you remember how to calculate the molar mass. For ionic compound, molar mass is the sum of the ionic mass. If you remember, ionic mass of certain anions and cations by adding simple, you can soon not find out the that 23 into 2, 12 into 1, your 16 into 3. Instead of doing like that, you remember carbonate ionic mass. Ionic mass of carbonate is 60. Ionic mass of carbonate is 60. Your 16 into 48 plus 12, 60. So if you remember the ionic mass like that, then you can calculate the molar mass easily. So sodium carbonate Na2, that means Na2, that is, or 2Na, instead of the Na2, then you can write it 2Na. 2Na plus That means that will be 23 into 2. 23. The ionic mass of sodium is atomic mass is the same as ionic mass because electron never take part in the mass calculation process. So sodium, though there is loss of 2 electrons, but still its ionic mass is the same as your atomic mass of sodium. So then 23 into 2, that is 46. 206 is the molar mass. As there is 2 sodium is there, so that means 106 by 2 is equivalent mass. The equivalent mass of sodium carbonate is equal to 106. 106 by 2 is equal to 50. Remember, 53 is the equivalent mass of sodium carbonate. Then you can calculate how to find out the decimal normal solution. So 53 gram in 1 liter gives 1 normal solution. Because 53 is the equivalent mass. Equivalent mass is equal to molar mass by 2. Or 2 sodium ion is 2 into its valence is 1. 2 into 1 is also you can write down. Or also you can write down equivalent mass of sodium carbonate. Also you can find out like this. Equivalent mass of sodium ion plus equivalent mass of carbonate ion. Also you can calculate like this. For any ionic compound, the equivalent mass of that ionic compound is equal to equivalent mass of the cation plus equivalent mass of the anion. So equivalent mass of cation is 23 by 1 and equivalent mass of cation is 60 by 2. So you see how to calculate the equivalent mass of any ionic compound. Remember, any ionic compound, the equivalent mass is equal to ionic mass of the cation plus ionic mass of the anion. In the sodium carbonate, there are 2 types of ions are there. Your sodium ion is the cation, carbonate ion is the anion, and the equivalent mass of any ion is equal to ionic mass divided by the charge carried by it. So equivalent mass of sodium ion is 23 by 1 because charge carried by sodium ion is equal to 1, and equivalent mass of carbonate ion is 60 by 2. Ionic mass is 60, 48 plus 12 and 60 by 2. 2 is the charge carried by it. Carbonate ion carrying 2 negative charges. So if you add 23 by 23 plus 30, that will be 53. So whatever way you calculate, the equivalent mass of sodium carbonate will be equal to 53. So if you take 53 gram and put it in 1 liter solution in the measuring flask, 1 liter measuring flask, that will give you 1 n solution. And if you prepare 1 n of n by 10, then you will take 1/10 gram equivalent, that is 5.3 gram. It is not necessary to prepare 1 liter, let us prepare 100 milliliter. 1/10 of this, 100 milliliter of it, then this will be divided by 1 liter equal to 1000 milliliter. 100 means 1/10 of that. So divided by 10, that means 0.53. So if you are adding exactly 0.53 gram and make it up to 100 milliliter in a measuring flask, and that solution will be n by 10 solution, n by 10 or n by 20 solution. So you see, this is the case how to prepare the standard sodium decinormal sodium carbonate solution. Now prepare decinormal sodium carbonate solution. And the hydrochloric acid, in this case, you approximately calculate, because that is not a primary standard, you approximately calculate the hydrochloric acid out of the concentrated hydrochloric acid. Concentrated hydrochloric acid is of 11.5 normal, or also you can take 12 also. So 11.5 normal is the normality of hydrochloric acid. Here normality is the same as molarity also. So we have to prepare, suppose 100 milliliter. We have to prepare 100 acid. Here you have to prepare how many milliliter you have to take? 3. So how many milliliter of hydrochloric acid you have to take? and you have to prepare say 100 milliliter. 100 milliliter of order n by 10. 100 milliliter n by 10 का dilute acid तैयारी करिया पानी 3 milliliter of 11.5 n दବାକୁ पड़े अर्थात कितने मिलीलीटर हाइड्रोक्लोरिक एसिड concentrated हाइड्रोक्लोरिक एसिड नहीं हमें पानी मिसाइले in a measuring flask of 100 milliliter we will be getting what n by 10 v1 n1 is equal to v2 n1 we have to getting into what n by 10 so n by 10 solution 100 milliliter करिया पाई 11.5 n रू कितने मिलीलीटर दବାକୁ पड़े so your v will be equal to 100 by 11.5 milliliter of what hydrochloric acid so our is a v will be about 100 by 11.5 v is equal to 100 by 100 n by 10 100 milliliter of n by 10 divided by 11.5 that means you have to take this and make your solution up to n by 10 100 milliliter then you will be getting your n by 10 solution so v milliliter of n by 10 solution will be obtained of the order n by 10 you have to take 100 by 11.5 and that will mostly come to 11.5 that will be 100 by 11.5 will be equal to your 8.7 that means in the measuring flask you take 8.7 milliliter this comes to 8.7 and 8.7 you make it 100 milliliter then that will be come to n by 10 and that will come to n by 10 so 8.7 that means in the this is your graduated pipette you take 8.7 milliliter to a measuring flask of 100 milliliter measuring flask of 100 milliliter this is a measuring flask or volumetric flask of 100 milliliter to this graduated pipette you can take your 8.7 roughly 8.7 milliliter because this is simply rough approximately n by 10 it will not be exactly n by 10 but here it is exactly n by 10 0.53 gram you have to accurately weigh it out and make it up to 100 milliliter but this is approximately n by 10 so you take 8.7 milliliter here then make your volume up to this as we have discussed in the previous experiment how to make n by 10 oxalic acid in the similar manner that is you are taking a solid substance here only you have to take here liquid substance in milliliter form and in that case we are calculating the solid substance in mass form that is in the mass form and here it is in the milliliter form so 8.7 milliliter and make it up to 100 milliliter and that will give you n by 10 solution to what extent it is exactly n by 10 it will be giving x n by 10 and that x may not be 1 but it will be less than 1 or more than 1 we shall have to calculate so what is the exact normality of hydrochloric acid that can be calculated by taking a standard solution here the primary standard is your sodium carbonate
so now as you all know that we are going to I'm going to demonstrate the process of titration so in the earlier experiments I have already told you about the burette how to fill it up here we are going to do the titration against Na2CO3 and HCl. So here we are going to take Na2CO3 in the burette. The way I have already told you in the previous video that you have to first rinse it, then fill the burette and fix it. Now as the burette is dry, I will not rinse it. If it is a wet one, you can rinse it. Now without rinsing and just because as the burette is dry, we can just take the final solution. So here I am taking Na2CO3 solution in the burette and the mark of the solution should be above the 0 mark of the burette. Then we have to just see this is the 0 mark I have taken but we have to take it more than 0 as we have to the volume, we have to fill up the air gap, maintain the air gap. Now I'm just maintaining the air gap. First we have to open the knob so that the portion below the burette air is being removed. Then we have to adjust the level to 0 by operating the knob. Now you see when you just take the observation, you just check it with your eye level. It should be with your eye level. Then you have to fix the burette in the burette stand and always operate the burette from the side base. And keep the conical flaps below it to know the height of the burette. Now I am just closing the knob, and before removing the hand, make sure that the burette is fixed. Next is our pipetting part. We have to take 10 ml of HCl in the conical flask. So pipette already instructed. You have to hold it with these 2 fingers, and this index finger should be free, and we have to suck it. Pipette is also dry, that's why I have not rinsed here. Now I have to adjust this lower canisters to 0. Now you see this is 0. Now no more solution will drop. It's 0. Next, transfer this solution to the conical flask from the pipette. After the solution is being treated, you see little amount of solution is there at the tip of the conical flask, which you have to tap the tip twice or thrice to drain the complete solution. Now you see there is no more solution in the pipette. Now we are going to add the methyl orange indicator. When we add the methyl orange indicator, it is light pink in color, which after titration it will become straw yellow color. Now I am going to add Na2CO3 from the burette gradually to the conical flask to complete the reaction or to complete the titration. So when the reaction will complete, the color light pink will change to straw yellow color, which is the end point of the reaction. At that time, we will get to know that reaction is completed. Let's observe. Always do the titration with a single hand. Now you see the color from light pink has changed to straw yellow color.
Now let us see what is the difference of the final burette is. Because this is the color change when it changes from pink to orange also. The yellow color will be in your alkaline medium and the acidic color is pink. So you see, now the final burette reading correction. Final burette reading is 10.1. 10.1. So this is 10.1 milliliter difference. So difference is 10.1, and in the next reading, this 10.1 will be initial burette because there is no loss of drop from it. If there will be drop leakage, then there will be difference in the initial burette. Here, if your burette is a perfect burette, then here is the final burette reading will become to initial burette. Then similarly, we repeat it. So that, let me say, we get 3 readings of 10.1. If you get the 3 reading 10.1, you need not go for the 4th reading. 4th reading is not necessary. But 10.1, you take it with a concurrent value. You take it with a concurrent value or calculation. Now, the normality will be in the normality of hydrochloric acid will be in the form of decinormal solution. Already we have prepared n by 10 solution of your hydrochloric acid roughly. So what is the exact normality of hydrochloric acid from this? We have prepared n by 10 sodium carbonate. So volume of sodium carbonate into normality of sodium carbonate or alkali is equal to volume of what? Your volume of hydrochloric acid and into normality of hydrochloric acid. Normality of hydrochloric acid. Hydrochloric acid we are taking 10 milliliters. So we have taken 10 milliliter of hydrochloric acid. Normality say n. Normality is not known, or this is V1, N1 is equal to V2, N2. So let us say N2 what is it? Volume of hydrochloric acid. Here normality is N2. Here volume of sodium carbonate is V1. Sodium carbonate we have taken. Sodium carbonate we have taken how much? That is the burette reading. Sodium carbonate this is the burette reading. Burette reading or titrant is the burette reading, and that comes to 10.1. 10.1, and sodium carbonate normality is n by 10. We have prepared that n by 10. So the normality of acid, the decinormal solution will order n by 10. So normality of acid, that is N2, is equal to 10.1 divided by 10 n by 10. This 10.1 into n by 10 divided by 10. So this will be in the order how much? This will be 1.01 n by 10. This is 1.01 n by 10. So this is the normality or normal strength of the solution. So this also you can calculate in grams per liter. So this is 0.10 normal. 0.101 normal. So the grams per liter, the strength also you can calculate. This is the hydrochloric acid. Molecular mass is 36.5. 36.5. If you multiply with this, then that will give you grams per liter. So grams per liter also you can calculate. So also you can put in this form also. The normal strength. This is called normal strength. Simple strength, you simply multiply the equivalent mass or molar mass to what? To the normal solution. Then that will gives you grams per liter. Grams per liter. because you know equivalent mass is equal to weight by gram equivalent equal to weight by E. So if E is multiplied with normality, that will give you the mass required. So mass required per liter of solution, you can also find. It will be better you represent in this form also. So if you write it like this, you write down the normal strength of the solution is 1.01 and by 10. And this is the actual normality of hydrochloric acid that you cannot find out directly by taking weight or volume, but you can directly calculate it with reference to a standard solution of which you can prepare the normality by taking the weight, exact weight and exact volume of sodium carbonate in a solution. So thank you all of you for your session here.